Now, let us explore some applications of geospatial data and satellite image analysis. The first one we have here is agriculture. In agriculture, farmers, policymakers, and humanitarian organizations harness the power of geospatial technology. Satellite images are invaluable for monitoring crops, and this technology allows us to do so with precision. Here's an example. In May 2023, the GeoGlam Crop Monitor map was released, showing crop conditions for the main producing and exporting countries, along with the countries at risk of famine. This information serves as a critical resource for decision makers. Urban planning. Urban sprawl, often described as the uncontrolled outward growth of cities, presents unique challenges for urban planners and policymakers. Geospatial data and satellite image analysis play a pivotal role in understanding and managing this expansion. Let's examine this through an example. In this example, we observe the expansion of urban sprawl from 1975 to 2015. This expansion takes different forms. Some cities exhibit polynuclear structures, where densely populated areas are connected by axes, such as Pakistan or Vietnam. Others, like the Hong Kong, Shenzhen, Guangzhou, or Macau urban area, have very high population densities within a vast perimeter of over 150 kilometers in diameter. In essence, geospatial technology is instrumental in navigating the complex dynamics of urban sprawl and shaping the cities of tomorrow. Now we have here environmental monitoring and geospatial data. Geospatial technology is a powerful tool for keeping a watchful eye on our environment. It plays a crucial role in tracking environmental changes like deforestation, both on a global and local scale. As an example, let's focus on a specific region to see how this technology aids in tracking deforestation. Let's take a look at Murray Forest Division. By comparing satellite images over time, we can unveil areas where our forests have been cut down, providing clear indications of deforestation. The image displayed showcases a change matrix in the forest, classifying areas into different categories, such as no change in forest, forest to non-forest, no change in non-forest, and non-forest to forest. This matrix provides valuable insights into the dynamics of land use and land cover changes over time. The land cover and land use maps highlight various classes, including state-owned and community or private forests. Data from 2005 and 2011 illustrate changes in forested and non-forested land. As mentioned in the source, the study's conclusion underscores the need for improved forest management practices, heightened community awareness, and incentives for local communities. Moving to the next application, detecting large-scale floods with geospatial technology. Geospatial technology equips us with the tools to efficiently monitor and assess flood situations, playing a crucial role in disaster response and mitigation. As an example, we have flooding near Sydney, New South Wales, Australia, 2021. Flood events can have devastating impacts on communities, ecosystems, and economies worldwide, often resulting in extensive damages. Ground-based assessments in flood-prone areas are challenging, and limited access to inundated regions makes it difficult to gather timely information about flood extent. This is where remote sensing, satellite imagery, and geospatial data prove invaluable. These images showcase the transformation caused by persistent rain and historic flooding near Sydney, New South Wales, Australia, in March 2021. The images were captured by the operational land imager aboard the Landsat 8 satellite. Comparing the before and after images, we can precisely identify the impact of the flood event. Now, here, these SAR images, captured by the Copernicus Sentinel-1 satellites, operated by the European Space Agency, help create flood proxy maps. The blue areas you see on these maps represent regions likely to be flooded on March 20, 2021. Now, the most crucial topic, air pollution. Geospatial data plays a vital role in monitoring air pollution gases, providing valuable insights into environmental changes on a global scale. It enables us to track the distribution and concentration of harmful gases in our atmosphere, helping scientists, policymakers, and the public better understand and address this critical issue. In recent years, NASA and ESA have pioneered pollution monitoring using geospatial data, focusing on nitrogen dioxide, or NO2, a harmful gas from industrial sources. The COVID-19 outbreak in Wuhan triggered an unprecedented drop in NO2 pollution. To understand this remarkable reduction in pollution, scientists turned to geospatial data. They employed satellite observations from ESA's Sentinel-5 and NASA's AURA satellites to track NO2 levels. This can be attributed to a combination of the holiday and significant efforts to minimize the virus spread. The other map above shows NO2 values over 3 periods in 2020. The 2020 values are compared to the same periods in 2019 for reference. Leifer noted that the overall values in 2020 were lower than 2019 due to new environmental regulations that China has enforced over the past few years. Groundwater monitoring and mapping. Geospatial data plays a pivotal role in monitoring and mapping groundwater, a precious resource that sustains life and countless industries. Here, we have an example. California water gains after record winter. The first image shows gains in the amount of water in the San Joaquin, Sacramento, and Tulare River basins in California from October 2022 to March 2023 as per GRACE FO data. This measurement includes water in lakes, rivers, reservoirs, snowpack, and groundwater aquifers. The second image is a line graph illustrating seasonal changes in the total amount of water contained in California's lakes, rivers, reservoirs, snowpack, and groundwater from 2002 to 2023. The data gap in late 2017 to early 2018 coincides with the decommissioning of the GRACE mission and the launch of its successor, GRACE FO. In summary, geospatial technology, fortified by satellites and comprehensive data sets, serves as a gateway to unravel the intricacies of our planet. From environmental understanding to the adept management of urban sprawl and the vigilant oversight of forests, it equips us with the discerning tools needed for informed decision-making in the pursuit of a more sustainable world. Thank you for your attention.